Hi guys, so in my 16th video in the DOWLATH revision series, we'll be discussing why ice doesn't melt at the bottom of the test tube. Now this and the previous one are basically very questions that can come both in multiple choice as well as a structured paper, and this is a popular multiple choice question as well. But I want you to understand a little bit because we'll use it as an opportunity to revise conduction. So here you have a test tube and you fill it with water and you heat the water at the top, not at the bottom, and you take a piece of iron gauze and you suppress 2 pieces of ice at the base of the test tube. Now when you heat the water at the top, you are not allowing the water to allow heat to circulate through convection currents, because as you guys can recall, when you think about convection is where you have a container, you have heat being applied, you heat the container, so the molecules towards the base become less dense. As they become less dense, these molecules in the fluid will begin to rise and the cooler, denser liquid will take its place. And the circulation of these currents are called convection currents. Now you cannot have that facilitated here because primarily of the position you're applying the heat. So because you're applying the heat to the top, when the molecules at the surface become less dense, they will rise, cool, but it's not like you have anything taking its place, right? And that will be, even if that's the case, you will have the cooler molecules going from the bottom. So it's not like heat is circulated for you to melt the ice at the base of the test tube. You will have then to rely on conduction, but because again the spacings between the liquid molecules are far apart, you are restricting the circulation of heat through conduction. Conduction is most efficient if the molecules are very close together. So what you will find here is that because you are relying on clusters of molecules which are spaced out, it will not efficiently conduct heat down the test tube to melt the ice at the bottom. So in this, the answer is typically that water is not a good conductor of heat.